Hello everyone, welcome back to my channel GapCard. So today we'll be talking about a dual slide shaper machine. So this tutorial will cover some aspects such as assembling and the motion study of the shaper machines, definitions and mode of application of this machine, how do we use them, what's brought about the use of these machines, and what is the usefulness. So I hope you will like it, and please ensure you share and subscribe to it. So what is a shaper machine? A shaper machine initially it is a reciprocating types of machines. That is the way the motion of the machine is a reciprocating type that is used for producing horizontal, vertical flat surfaces, which is designed for giving a desired shape of the surface. That is, it is used to make the shape, forming procedures on the workspace in respect of the designs or pattern you want to achieve. So nowadays, industries, companies in the world attempt to accomplish a high creation rate at a negligible measure of times, cost, and so on. So the use of a double shaper machine thereby decreases times and whereas production costs. So the reason why we are trying to design, or the reason why they design a double or a dual shaper machine is just to what, to decrease times and as well as production costs. That is the difference between a single shaper machines and a double shaper machine. Those for efficiency and time reductions and to increase productivity. So I hope you will enjoy it. So let's go on in assembling and trying to get the motion study using Solidworks. So today class we'll be considering this type of a dual shaper machines, which consists of the frame, the pulley, you can see it there, the shaft, the belt, a slider, the clamp at the both end, and a prime mover. So this is what consists of a dual shaper machines. These typical dual shaper machines, and I know you guys have with the tutorial I've explained earlier. You should be able to like assemble, draw all these parts individually. So the first component you will pick first is your frame, which serves as a fixed support in mechanism, and you have to ensure the first part you pick, because in SolidWorks the first part you pick, or the first component you pick in your assembly will always be fixed. So I'm going to be taking my frame as the first part. So the next one I'll be taking is the pulley. So I'll go to my insert component, I'll go to browse, so I can pick the many ones that remain. I can just press my control key down, press my clamp, the pulley, and slider pasting, and drag everything to this side. I can now release my control key and drag everything to this side. So it's me my prime mover, but at first let's try to assemble this part first. So you can try to adjust it, and so the first part I can just pick my pulley and try to position it first. You can just pick anyone. So in assembly I will click on the most of the common mating we do in assembly is concentric and coincident. Concentric in such a way that if we have two circles of similar diameter, or if it is circle, concentric is, you can use a concentric function, that is it's only work for where you have a cylindrical faces or a circular faces. So and coincident is just that it's touching each other. So in this part here I can mate this pulley with this my frame here using a concentric method. Like so, you can click on your mate, then click on the shaft, of the pulley, and come closer to this concentric or the circle in this your frame, and for it to form this, and you okay, you can drag it and drag it. And try to click on this face to align with the space of this by and click on OK. So the next one is we pick our slider. We're missing our slider. So in this mechanism now, the next one that remain now, so you can see that the free body diagram of the slider is it can only move in one motion. It can move not only one motion, it can move in two motions, which is something to this side and a linear motion. So you want to make sure the slider has the same motion with the pulley. I get it now. So the movement, the free movement between the pulley and the shaft will be the same thing, likewise the one for the slider. So to do that, so the next thing to do is, since we want a motion that a link that will come from the shaft to the slider, we want to create a link, a kinematic link that can be formed between this shaft and this slider. So we'll go to our mate. When you click on your mate, so instead of using this normal standard of mating, which is the coincident, parallel, perpendicular, we won't go there. We'll just move straight to our mechanical. So in our mechanical, we have some mechanical mating, which have like cam and shaft in the engine. We have this key and slot in all this pulley. You understand? When you have this pulley and to tighten it, there's a slot or form of slot like that. You also have hinge, which is using all these cars. You have gears, different mating aspects in mechanical. So we want to work on slots. So we pick the two components we want to fuse together, and mate it. So now they have the same process now. So you can try to like analyze the motion mechanically and see how it should be. So you can see we are getting what we want to achieve. The link is not being paired between the shaft and the slider. So we are good to go. So the next assembly we would like to do before we do our basic motion is the clamp, which is fixed at both sides. So the next one is to mate our clamps. So you can also ensure you open the command for mate, and you get assured there. So we need two clamp. We can see drag this, or you can just cancel the mate first and try to position your clamp to where you want it to be. So and drag it. Ensure it is facing the right direction. So from here you can also try to mate it now. So you click on your mate, and this mate now is now a different with what you have been doing before. Initially we are using concentric and coincident. So in this place here we are going to be working with lines. So we are going to be working with edges and vertex. So in this place we will look for two edges that are parallel to each other. So instead of me pressing coincident, I'll just press they are parallel and click on OK. The next one, so I can click on the other edge of the frame part and other the edge for the clamp, and also put they are also parallel. So I will move on to you can now try to adjust the body. You can just click on this body too again and mate. So gotten where we want to put. So you can also do other likewise the same thing for the other one. So instead of you going back to your insert component and look for the gym clamp, you just press your control key down and left click and drag your press your control key, you left click, and you just drag your another type of G clamp outside, and you release your same function, just like what we did for the other one. Perform the same function by mating this other side with it, and try to achieve the same thing. So you can just work around and do the same thing. So you can play around with the shaft and see if you are getting what you want to achieve before we do the basic. So you can see that we are already getting, even though before we do the basic motion, we've already tried to do the motion mechanically by ourselves, and we see that we are getting it. That's one of the step you have to take note when you are doing your assembling using Solidworks, and you want to ensure you want to do a basic animation or a motion. So you have to ensure you use the right assembly or mating part, because if you don't use the right mating command, it will surely affect your basic motion in terms of when you have fixed mating or a coincide mating that the two parts can't be moved. I getting, so it will surely affect your basic motion. So that's the reason why when you done any mating command, try to play around where you do the mating to see maybe it's actually giving you what you want to achieve. So the next one is to bring on our prime mover and connect it with a belt or the prime mover, and try to install it on the ground level, and ensure you make a power transmission means, which is a belt connecting the pulley of or the shaft of the belt of the prime mover to the shaft of our pulley. So try to assemble this prime mover and invest with our pulley. So after you've done that, so we position our prime mover directly directly to the ground level of the frame. So you can see we're going to use power there to this edge of ground level of the frame, and likewise the other side too. Power there. So we've done that. You can now like drag your the next step is to create our belt profile, connecting the DC motor or the prime mover to the pulley, so that it will be able to drive the pulley and send a motion or an energy to the slider. So how you get our belt profile, you go to the assembly features, you see some commands under it, you go down to our belt and chain. So after you click the belt and chain, so a command will pop up here and tell you should pick the component you want. You ensure we pick the body, the extrude body of the pulley. So a circle will be created at the middle of the pulley. Then click on you can just try to analyze by picking the shaft of the DC motor. So we can see that our belt profile is already formed, trying to link the prime mover with the pulley up. So since we've got what we want to achieve, then we can click on what OK. So that's now we've gotten the connection from there. So it's now left for us to create a belt with it. So we can just come here and when you click on this small row, before you click on this small row, try to right click on the belt and you see edit features. So you click on edit features. So try to scroll down and say driving. Click on the driving, that is you want it to be driving, and you use the bed thickness, and you want to create a bed part. So you click on OK. After you've created a profile like this and you ensure you create a part, so from there you can just come to this place, you right click and you want to write edit features, or you just open the part. So after you open the part, what you want to do is you want to create a belt profile. So it should not this task should not be something hard for us. We are going to use a sweep command, just as the way I've explained the sweep command for us. So it's not going to be hard. So you can see the part here. So you try to create a sweep command, getting sketch of stuff on. So after we've designed the belt, so this is what we are having now. So our yoke, our slider or shaper, glass shaper machine is ready. So this is just a typical shaper machine which we want to just analyze the basic motion of this simple setup or simple mechanism. So we are going further to the basic motion. So in one of the condition or one of the aspects about basic motion is you have to position your machine or your mechanism in the right positions, because the initial position it's occur or you put it, that's what is going to start using to what simulate. For example, now if my machine stand like this now and I open the motion study, so this is how it's going to start taking this reading form. So you have to know the actual way you want your machine to be positioned. So if you want to position your machine very well, so you can go to this view and try to play around with the isometric or the diametrics to see how you want your machine to stand. So but I would prefer it standing in this way, so we can see both the prime mover, the pulley, and at least you can see the slider. So we move on to the opening the motion study. So you click on the motion study, and so we are on the second aspect of this tutorial. In this aspect, in this motion study, we have the animation and we have the basic motion. So we want to work with the animation to see how it's going to be moving, and in the animation we have some commands we are going to be specializing on, some conditions which will allow our system to work fine. So these start from the settings. We have the motion study properties, we have the gravity, we have the contact, we have the spring, we have our motor, and so on and so forth. So firstly you go to your settings, you start from the right to the left, and that's how the principle works in. So in our animation, so this, what does it really mean is you say frame per second. So you want to calculate in the total frame, like what you want to capture within a second. So let's ensure you have a wider frame. I get it. So the main purpose of this one is also have a wider frame. So for per second, the way it is working, what is going to be capturing. So I can just put it to 15 and try to look around if there's any other condition to meet. If it's only this, you can also put OK. The next one you move to, we don't need a contact. Why we don't need the gravity? Because we are not doing anything that has to do with the selection due to gravity. Nothing is falling. Are you getting it? So we just want to have a mechanism, a principle, how the power is being transmitted to the prime mover to the shaft. So the gravity might be neglected for a while because it doesn't have a real effect on it. And the contacts, we won't be using much of the contacts because mostly it's going to be made for this kind of follow-up stuff, but we are not going to be using it. And likewise spring, we are not going to be adding a spring because a spring is a flexible joint and we don't need it for this place. We are not absorbing any energy or any shock, we are not controlling a motion, so we don't need it. So the next one we can just move to is the motor aspect. So mostly this is one of the major tools you use in animation. So in motor we have the rotary motor, we have a linear motor. That is, how do you want your machine to move? Is it in a circular motor or in a linear motor? So you can just ensure you pick the rotary motor. So when you click the motor, you will see that it's quite different from the linear motion when you click. So I can just pick on, you can decide to pick on your DC motor, your prime motor, or just ensure you pick a component that is rotating, a flat surface that is rotating. So ensure, note the direction of it is moving, that is moving clockwise,ly it's moving clockwise,ly. So, and you have to click on the body if with respect to. So I'll try to like, so it's moving, the body is moving relative to, so I will choose this frame as my guide. Then I'll try to increase the speed. 100 revolution per minute is so low, so I can just use like 20 revolution per minute, and click on OK. So I can just try to work on the on 50 seconds, and see how it's going to work. So after we've done met the conditions for our animation, so the next thing is to calculate and see how it goes. So you can just start getting your calculation ready, and you can just relax for a while and let it calculate on its own. So you can observe these seconds moving, trying to see how it's going to move. So you have to just relax for a while until it reach 50 seconds. You pull down, you allow it to wait to 15 seconds. So you can see how the brow shaper machine is moving from the DC to the pulley, and from the pulley in the shaft try to transfer the energy to the slider. So this is just a basic motion, or you can call it an animation of a double shaper machine. So this is it. So please ensure you, I hope you enjoyed the video. So please ensure you like, share and subscribe. God bless you all. Thank you.